Hey guys, so I'm gonna do number 17 from the 10.6 homework that's talking about the alternating series. So in this question, I'm getting determine whether the following series converges absolutely, converges conditionally, or diverges. So to get straight to the point, so we have like one of three options over here. It could either diverge or it could either converge absolutely or conditionally, right? And so we know that for say absolute convergence, just a sec, there we go. For absolute, like basically, from this absolute sign, then you'd have say the absolute value of a of n that's gonna converge, right? And don't forget about your segmentation. And for the conditional over there, you're gonna find that the absolute value of the sum of the series a sub n should diverge, but the non-absolute value in this case, uh, the sum of a sub n, notice that I don't have the absolute sign over here, should converge. So that's gonna make it, let's see, conditional, right? Okay. So in this case, rather, we have the absolute value of cosine k over 5k to the sixth, right? Then you got sigma k is equal to 1, then infinity, right? But for a fact, we know that since k is equal to 1, then whatever value of k we're gonna input here, it could be 1, it could be 10, it could be 100,000, whatever, it's still gonna be positive, right? So simplifying that, we're gonna get the absolute value from k is equal to 1 to infinity. The absolute value of cosine k over 5k to the sixth, right? Because, for cosine k, say, you might get, for example, cosine of 45 degrees, right? Which is 5 over 4, which is root 2 over 2. Or you might get, say, cosine of 135 degrees, for instance. It's negative root 2, negative 2 root 2. Then the absolute is gonna, take the negative sign off, right? So, now that we've established our A sub n, and so on, right? So we have to use another test to distinguish, say, this from this. We have to, kind of compare, right? So on that note, then we're gonna have to use the series comparison test. Series comparison test. Thank you. So for the series comparison test, we need our A sub n and B sub n, right? Taking, for example, like, say, these two numbers are positive, for sure, right? For increasing values of n, right? Like, n is greater than or equal to 0, something like that. So we're gonna take, for A sub n, we're gonna take the whole function over here, right? Whereby you got cosine k over 5k to the sixth. Don't forget absolute value is equal to, and so this b sub n. So we want something that's gonna help us compare, you know, cosine k and k blah 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 whatever. In this case, I'm gonna choose to compare it to the denominator, right? 5 is just a number. It's pretty much a constant, so that can go off. But I'm more or less what do you call it? I'm more or less concerned about this k over 6. So my b sub n is gonna be 1 over k to the 6th, right? And I have to I have to like establish which of these two series is bigger than the other, right? So I could have a lot of values over here. Like say, for instance, I have for k is equal k, you have cosine k over 5k to the 6th. And then let's see, 1 over k to the 6th. Like, that's just pretty miniature table I got over there. So take k is equal to 1, right? Because we're talking about greater than or equal to 1, right? So 1, that's going to be cosine of 1. So 0.50 divided by 5k. In this, and we said k is 1, so 1 to the 6 is going to be 5. So divide by 5, 0.108. And 1 over k is 1, right? So that's going to be 1, right? We don't need too many values. We just need like a couple of them. So cosine of 2, I'm going to do that all together. Cosine 2 over 5 to raised to the 6th. So you got a negative value that's close to negative 0.0013, right? And if I take, say, for instance, 1 over 2 to the 6th, 1 over 64, which is 0.0101565, right? So at this point, we can establish that 1 over k to the 6th is greater than cosine k sec. Yeah, is greater than cosine k over 5k to the 6th, right? So therefore, we have cosine k over 5k to the 6th less than or equal to 1 over k to the 6th, right? So we can establish that whatever value or whatever the fate is of 1 over k to the 6th is pretty much going to be the same for here. Because going back to this example, for instance, like if b sub n converges, then so does a sub n. And if a sub n diverges, then so does b sub n, right? So it's pretty much the same. In that case, so remember this are b sub n we chose. And so we gotta find the fate of this series over here. So on that note, let's see. Oh, don't forget this. Sigma k is equal 1, infinity. K is equal 1, infinity. K is equal 1, infinity. Then k is equal 1, infinity. Okay, so on that note, now we have to find what exactly happens to 1 over k to the 6th, right? So here we're gonna look look at another friend of ours, that is the P series, right? Whereby you got sigma, say headed to infinity, k, or is it k or n? Yeah, it should be, okay, k. K is equal to 1 over p to the n, right? Whereby n is greater, oh, sorry. Yeah, so this is p. Whereby n is greater than 0, right? So we know that the power over here, if n is greater than 1, then our series converges. And if n is greater than 0 but less than 1, then this series diverges, right? So on that note, we have, break this guy down here. K is equal to 1 over k to the 6th, right? So in this case, we can establish that n is 6 over here, right? So since n is equal to 6, and n is greater than 1, then we can conclude that this series converges, right? So one of our friend over here converges, right? Therefore, I'm gonna write that down. So k is equal to 1 infinity, all right? 1 over k6 converges by the P series. And since this guy Bn converges over here, then this guy has to converge as well, right? So eventually, let's see, infinity k equal 1, then cosine k over 5k to the 6th converges, cos b sub n, or in this case 1 over k6, converges as well. And for this, we had to use a series comparison test. So by the series comparison test, and since remember there's an absolute value, then we head back to the top. The absolute value of a sub n converges as well. So, and it's absolutely, sorry, I forgot to mention that. So on that note, Lu con there you go.